is Zan Pichand and welcome to my mathematics class. I think all are fine and rocking. Okay, let's move today's topic. Today's topic. Today's topic is limits at infinity. One video already I have made on limits and infinity. So today also I will tell you how to find out the limit at infinity of these type of functions. Very simple questions I have taken today. Very dead simple questions. In last video I forgot to take these questions. Okay, so today I have taken. Here we go. Solution. First question. Limit of rational algebraic function, you can say, for x squared plus x plus 5 at x tends to infinity. Okay, if you say directly x square, then x tends, 3x square also tends to infinity. As x tends to infinity, 2x tends to infinity. And plus in 1 means infinity. In numerator we are getting infinity, and in denominator you can see as x tends to infinity, 4x square tends to infinity, x also tends to infinity, infinity plus 5, so again infinity. Clear everybody? So here we have question in infinity upon infinity form, which is called indeterminate form. This means we have to simplify. Here see, if you see very carefully this one, you can factorize here. So how to simplify? If you get these type of questions, you need to take common variables having highest power in numerator as well as in denominator. So see, limit as x tends to infinity, common here. So here, which one? Here x square, here x power is 1, here is x square power is 2, so variable having highest power means this one. So let's take common x square, and inside the bracket you will have 3, and here x is already only x inside in term, but we have taken x square, you need to write down x in denominator. So now when you will multiply this into this, 3x square, this into this means 2x, alright, so fine. And here 1 upon x square. Now okay, alright. If you multiply, you are going to get numerator. In denominator, same method you will apply. X square common, 4 plus 1 upon x plus 5 upon x square. Now limit as x tends to infinity. Here 3 plus x square cancel out, or they can be cancelled. 2 upon x square. Here 4 plus 1 upon x plus 5 upon x square. Now, so one thing already we have discussed, 1 upon x tends to 0 as x tends to infinity. It doesn't matter here 1, 2, 3, any real number except 0. So always tends to 0, okay, as x tends to infinity. So 2 upon here, if x tends to infinity, your 2 upon x also tends to 0. And 1 upon x square also tends to 0. 1 upon x also tends to 0. Already I have written here 5 upon x square also tends to 0, okay. In which case, okay, they tends to 0 when x tends to infinity. Okay, using this concept, we can write down here. Now this is not in indeterminate form. You can open, you can find out the limit, and it's gonna be 0. As I told you, as x tends to infinity, 2 upon x tends to 0. So 0, it becomes 0. Here also, this also becomes 0. 4 plus this also becomes 0, and it's gonna be also 0. Okay. So your answer 3 upon 4. 3 upon 4 is the limit of this function as x tends to infinity. Clear everybody? So I think you clear. The same method you will apply here. I'm not going to solve these questions. I'm not going to find out the limit of these functions. You can find out yourself. These are that simple questions. Number 2, number 3, number 4, number 5. These are all questions I have left for you for practice. I hope you will do practice here. And same method, okay, exactly the same strategy, same method as I have applied in first, you can apply in the remaining questions. Number 2, x square common, here also x square common, x square common, same method. Here also x square common, x square common, x square common, x square common. Alright everybody, so today I have given to you for practice very simple questions. Okay, I hope all you will get the answers, right? So these are very simple questions, so no need to write the answers for these questions. Okay, I hope okay you will be supremely confident about the answers after doing the first question. After looking this the method of doing first question. I'm sure you're gonna get all questions very easily without any confusion. Okay, everybody. So I think enough for today. So I made today very short videos. It's okay. Sometimes okay short, sometimes okay long. But you should watch these videos. Okay, these are very important if you are the students of mathematics. Okay, if you need calculus, then also you can go through all my videos. These are very important for all. Okay, thank you for watching my videos, and if you are newcomers, please subscribe and like and also comment. Okay, have a wonderful day. Okay, bye bye.